So if you feel too tired, you can rewatch.
Well, I've been working quietly every so often on resuscitating Strong Talk. So therefore,
Oh,
wow.
given today's talk, I felt I should put in an appearance. I think I've broken it.
Nice.
It's not actually working right now. But when the UK Smalltalk people started their COVID presentations, I had the dubious honour of giving the first presentation, but it wasn't recorded. So, yeah, it was my first time giving a presentation actually as well. So it was pretty rushed. But hopefully, in due course, I'll be happy to update people on it.
Well, if this is an okay time slot for you, you're welcome to present.
I'll keep it in mind.
Okay. Hey, Leandro and Connor. Just saw this here too. Alex. Oh. Hey, Alex.
Hey, Alex.
Hey, everyone. You hear me?
Hey, haven't seen you in a while. How's it going?
Oh, good. Just working a lot. But
Same.
I'm missing everyone. Yeah, it's nice to see you all.
Yeah, likewise.
Ishki.
Yeah, we're gonna give folks a few minutes to trickle in before we actually start, so feel free to chat. Yeah, everyone should have a guitar in their room background.
Totally. Oh, does anyone here have a Linstrument? I'm thinking about getting one. It looks really cool. I almost built one from scratch, but it just seemed like too much work. And
what is it?
It's a really cool MPE controller that has it's basically a grid, and it's set up in fourths. Those are the intervals, kind of like strings in a bass or whatever. And it's a MIDI controller that lets you do multi-touch, and it does pressure. It's really expressive. Apparently, it's like Rolly, the C-board, but in an isomorphic layout.
I like these for that even more. The Rolly light pad.
Oh yeah, those are that's a neat idea. The Linstrument is just much bigger though.
Yeah, more
which
keys.
is why I'm attracted to it.
Yeah.
But that's super cool. I've been wanting to try one of those out.
Yeah, it's fantastic. I really like them.
Very cool. Hey, Dan, are you in Manhattan Beach these days?
I am. Yep.
Okay, cool.
Yeah.
We should see if we can organize something for the Southern California contingent.
That's right. Yep. I kept thinking the COVID was going to end and we'd be in a pub by now, but we know how that went.
Yep.
Any week now.
I've been a little bit paranoid because my kids can't get vaccinated because they're under 12 and thing. And just this week, we found out a couple of days ago that one of the kids in Isabella's class got COVID, and a bunch of the kids got quarantined.
Oh, geez. Yeah.
So, luckily, not her, but what a mess.
Really.
This seems like a good amount of people already. Craig, what
Yeah.
do you think?
We got 22 of the 60 people who RSVP'd.
Oh, okay. Then usually we give them 10 minutes after
10,
the hour.
10
so,
past, yeah.
yeah.
Hey, Mike.
Of course, there's the other theory, which is that we should not honor those who are so slow and reward those who got here on time, for gosh sakes.
Eh.
I've been sitting on the screen.
We're in California. We're in no rush.
That's right.
I spent the last 5 minutes sitting on the screen, not noticing there was a button saying join meeting.
Yeah, I know that one.
Mm-hmm.
It only gets worse.
Glad you found it.
No, I'm still hoping to meet all you cool guys.
Oh, did we tweet again?
Oh, no, I'm too busy
gonna-
getting the meeting started to do that.
Yeah, I was thinking about it and then I got into chatting, so I'll see if I can do that now.
Yeah, good point.
So it's interesting. I can tell all the people who have big screens up above. And you know how your laptop comes with a camera at the top of the screen? Maybe the big screens should come with a camera at the bottom.
Mm.
I could break out my external camera.
Yeah, yep.
For
Hey.
New Year's Eve, I did a 2-camera shoot for the New Year's Eve party.
I usually join meetings twice, the second time on my iPad just for the camera at the right height.
There you go. That's Craig. He's got the technology worked out.
Well, mine was a dance party. I wanted to be able to get both my full body in frame, but still be able to see the screen. So I had an external camera and a video projector. It took me 2 hours to rig it all up.
All right, Mexico. Hola, Alejandro.
Hola, hola.
Hey. Okay, tweeted.
Oh, thanks.
And retweeted. That always feels so fake. If you tweet something, then you switch to the other account and retweet it immediately.
Oh, yeah. I can pile onto that.
Mm-hmm.
Well, how many have we got on board at this point?
Okay. Oh, 24. We're slowing down.
Yeah.
But it's 10 past anyway.
Yeah. Well, I might just start off and welcome everybody. And Craig usually does this, so I'll probably leave something out. So Craig, please interrupt me. This is the welcome to the meeting of the California Smalltalkers meetup, which we do every the second Wednesday of each month, as best we can. And we tend to start off with, well, as you can tell, we start off a little bit late. You're not supposed to know that. You're supposed to be here at 6. But anyway, so be it. And we start off checking with everybody about any announcements they might have. So has anybody got an announcement of general interest they'd like to make? Stuff coming up or stuff that happened that everybody ought to find out about?
Something more personal, not directly related to Smalltalk, but somewhat. Our company launched, I guess is the pronunciation.
Yeah.
2 weeks ago now. Croquet, with the original version, was in Smalltalk. The new one is not. But it's still half the team, at least, was in LNK's group. So Yoshiki is here. He's on that team too. So yay!
Yay! Congrats!
Congratulations.
Oh, Dan is here too. He's part of that.
Yeah. And I have a minor announcement, which is just that things are going along with my attempt to get Smalltalk 72 running in itself. And it was a project that I had running in JavaScript, but it seemed to me just wrong to not have it in one of the chain of Smalltalks. So I've just got that going. There are a number of things that need to be fixed yet, but my hope is to show it to folks next month and put it out where you can play with it. Because I want some help in the harder part, which is to actually get the interpreter running in the language itself. That's the goal.
Cool.
I just have one minor announcement, and that is this is my first time at California Smalltalkers, so I'm very pleased to be here. And I've missed a few late nights or early mornings, but I think it's worth the effort. So, hello from London.
Welcome. Thank you.
I wanted to say hi too.
Andrew.
Hi there from Portland.
Andrew.
It's taken me the last 15 minutes to figure out how to actually join the meeting rather than just viewing it on YouTube, which is the link I was given. So there's a little success for technology. Looking forward to seeing you. Well, I have been seeing you, but I haven't been able to say hi.
Oh, that's great. It's good to have you here.
Welcome.
Yeah, I'd like to say hi as well. Temporarily in Madison, Wisconsin, but from SoCal. So this is the first meeting I've been able to join. But been dabbling in Smalltalk for an awful long time. So first time I heard of this, I joined up. So excited to meet all of you.
Welcome.
Welcome.
So after any announcements, and feel free to interrupt if you have another one. There's also time for anybody to give a lightning talk, something 5 minutes-ish. If anybody has anything of that nature they'd like to put out right now, this would be the time.
The only minor thing, it's not really a lightning talk, but specifically for you, perhaps Daniel, is I was very pleased that I was showing somebody Lively yesterday saying, I'm sure things could be quite different. And I was able to do the rotating star on stick on rotating star trick. And that suitably blew him away. So
Awesome. Yeah, it's my favorite demo.
It's still amazing what people find amazing, but it is amazing. So.
Well, the thing is, it's the wonderful thing about these engines is that they're live mathematics. And I think that's an aha you get when you do that, because the last little thing you do, your mind knows that that's what it should do. But then when it actually does it, it's like this big piece of trust that comes along. Holy cow. Yeah, glad you enjoyed that. That's great.
Well put. And it was, exactly that. And literally the spinning star on stick on spinning star it's such a simple demo, but it works so well, like you say. But anyway, there you go. I'll shut up now.
Cool. Okay. Any other announcements or little lightning talks? Okay, well, it's my great pleasure, my honor to introduce Gilad Bracha, who most of you surely know already by reputation, if not personally. And Gilad's done a bunch of great things. And, I was thinking that, when you build something, there's always hope that somebody will come along and see its potential and make it even better. And Gilad has done that several times for Smalltalk, and it's really great to have that. The first one that I know about is the Strongtalk type system, which it's a beautiful job. It puts mixins into the original Smalltalk 80 library, makes it simpler and more general, and then it gives an optional type system. And you would think that with an optional type system like that on top of a nice dynamic language, it would have ended all the endless conversation about types versus, static types versus dynamic types. But no. And then after the Strongtalk work, he went to Java land, and got closures into Java, which was a great thing. I think it sort of went a different way at some point, but that was a great contribution. And then out on his own, kind of got to work on Newspeak, which adds more beautiful simplicity and generality features, I think, which he'll tell you about. But the fact of just taking classes and letting them do the work of namespaces, and even just reorganizing essentially everything. So Gilad, I'm sure, can be much more coherent about this, and I want to give him to you all now to tell you what he's done.
Thank you, Dan. That is the greatest introduction I've ever had, and good it's recorded, because I'm going to keep that one.
Awesome.
And now I'm going to try and share my screen again. What does it want now? Start upstairs. Yeah, well, I'm trying to. Okay, I think it stopped the camera instead. So that wasn't what we want. I clicked on the wrong thing. Okay. And we will, we're back to the same problem. Okay, here we are. Now I know what the problem was, by the way. But okay, we can share the screen. And this is the greatest challenge of the day. Because that was the one technical point I was worried about. And hopefully you can all see a browser that says Newspeak on the web.
Yep.
Awesome. So I'll make it just a tad bigger. And so thank you all for attending. And thank you, Craig and Dan and Vanessa, in alphabetical order. Sorry, Vanessa. Yeah, for giving me the opportunity to speak here. So I'm supposed to tell you why this is true, why Newspeak is double plus good. And just quickly, here's the family tree for Newspeak. So you can see it has a very distinguished lineage. We claim royal descent directly from Smalltalk. And the other logos are other languages that have had some influence. The bigger the logo, generally speaking, the bigger the influence. So the biggest influence is Smalltalk. Self and Beta are the other major influences. E, which is an O-cap language, and we'll explain what all that means as we go, by Mark Miller, is also important. And there's just a tiny bit of influence from Scala that you really have to know where to look for. You wouldn't recognize it just by looking at the language at all. But I do know that it influenced my thinking about a few details. So what is Newspeak? Well, it's a language in the Smalltalk family, but it's not Smalltalk. It's a different language, and it can be described by this series of buzzwords, some of which are obvious, like dynamic and class-based, some of which are slightly less obvious, and we'll explain them as we go along. The thing I want you to remember right now are these two defining properties of the language, which is that all names are late-bound, and there's no global namespace. And once you take those two things seriously, the language more or less designs itself from that point on. And it is quite interesting, I think, what we get. So, okay, Chrome behaves differently. Huh. Okay, well, we'll click on this and hope for the best. Yeah, so this is the Newspeak ID running in the browser. I guess I have it in full screen so you can't see the URI, but this is on the Newspeak website. And we'll just play with it a little bit to give you a sense of what things. Is this big enough? Can everyone read this comfortably?
Yeah.
Yeah. Okay, so this is a workspace which does sort of what you'd expect. So if I select this and press that, we get 7. What you might not expect is that 7 is a link. And so if you click on it, you get an inspector on 7. And you can see that it's a small integer, which you'd also expect. And you can evaluate things in the scope of 7. And I can use the keyboard. And I get 21. And this is a link again. And let's just for fun do this. Live evaluation means that we get this to evaluate on every keystroke. And you can see, well, S, there's no such thing as a method for S in small integer. Now, you might think, why doesn't it say undefined variable or out of scope or something? Because there are no variables, or rather, there are variables, but you cannot reference them directly. So this sounds a little like read-only memory or write-only memory, but it isn't. It just means that everything is a message sent. Remember, we said everything is late bound. What that translates to is everything is a message send. So you cannot actually speak of variables or anything directly. You are always getting at them through an accessor. So once we get to self, we've got 21. And there we have 42, which is the end result of any proper computation. Okay, I'm going to exit full screen because otherwise Chrome behaves differently than some of the other browsers and I can't get at this, which is the back button, which I need. So basically you can navigate back to where you were using the back button. So we can go to 7 and we can go forward back to 21 and we can go back to 7 and to the, what did happen here? I don't know, Chrome is behaving strangely, but you can expect glitches. I guarantee you this system still needs a lot of work. But the navigation model is something we had in the, most of you may be aware that there is an earlier Smalltalk-based version of Newspeak. But this UI model is something that Vasily Bykov designed for us in 2007 as part of that system. And it was navigation-based even in the system that ran on top of Squeak. And it is, of course, a very natural fit with a web browser, not coincidentally, and with mobile. And so this is this allows us to fit in and take advantage of the browser in various ways that you'll see. Now, I told you various ways to evaluate this, like by selecting it, using the keyboard, using this button. But suppose I wasn't here and you had to figure out well, how to use this thing. This is what the question mark is for. So that's a help button. And here you can see, well, it tells you this is an object presenter, which is what we call an inspector. And it describes the various widgets in the presenter below. And they actually are live. So if we choose to select 3 and press evaluate selection here, well, we get 3 just as if we pressed it in the browser itself. Right? So they're live widgets inside this help. So let's see where this help comes from. And I can do that. We have this inspect presenter option, which I try to put into every system I can. And that'll let me inspect the UI widget that is actually presenting to me now. So if I click on this, I have another object presenter, but this one is on object presenter. Right? So it's actually inspecting the object presenter, which was showing me the workspace before. And let's open the help again, and it's pretty much the same thing, except that this says class object presenter, and that one says class workspace. And now I can look at the code in the object presenter class here in context inside the object inspector. And as you can see, these are tree style presentations. They're not the classic Smalltalk version. We've been using these for a long time. Vasily put them in, but they're closely related to the ones we had in Strongtalk, and those are all, they all go back to self, which had something of this style. And it has pros and cons, but the pro is you can look at multiple methods at once. The method we want to look at is this one we called help text. And look, it says this is an object presenter, blah, 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 which is sort of exactly what this says. So this is where the help comes from. And it's HTML. As you can see, there are divs and there are, breaks and all this HTML kind of noise. And just to show you that this is the real thing, we can can edit this and accept that. And lo and behold, we've changed it. So this really does control the display. And now we're shouting that this is an object presenter. If we go back, the workspace one also shouts that it's an object presenter. So we've changed the help live as you'd expect. And the nice thing about this is that I didn't have to write an HTML parser and render, right? We're running in the browser and we can do all that. The thing that's not so nice is that I really don't want to write HTML. I would like to have a live rich text kind of WYSIWYG kind of thing that produced this HTML, and we're not there yet, but it will come. But just to illustrate kind of what we're shooting for, let's evaluate this and go look at this list. And it's an empty list, so it's not very interesting, but we can add stuff to it. Notice there's no self, right? We don't need to say self. As in self, we do not need to say self. It's implicit. But the rules are actually a little more complicated than self for reasons I won't go into, basically because of the nature of the class nesting. But I can evaluate this, and you can see it evaluated to 3, and the list display updates and so forth. Now, the reason I'm showing you this is because I put in this nice feature, which is a copy of a demo feature we had in Strongtalk all those years ago. So it's 25 years old in principle. But if I make this a do it button, now this is a button, and I can click on it and keep adding stuff to the list, but it's also still text, right? So if I do this and evaluate that, that's kind of nice. It doesn't always work, I'm afraid. So the parser gets confused when you do it, add things on the other side. You can see the colorizer is telling us that it's unhappy, and should I be foolish enough as to evaluate this, it tells me that there's a problem. But this is nevertheless, text that I can edit and do things with and delete and so forth. And we basically want to get to the point where you'll be able to do this and also show you modify the text live and all this interactively. It'll come. It'll take time. But that's kind of all benefits from our integration with the browser. So how is it that we actually get at this stuff? Let's see. So what this expression should do is it gets me a JavaScript object out of platform. The platform object gives me an object that gives me JavaScript. JavaScript gives me its globals. I look up the DOM parser, and here it is. And this sure as hell isn't Newspeak. This is JavaScript. You can tell by its beautiful syntax. And so we can inspect it, and we see that it has a prototype of some sort. It has a name and various other fields. So we can actually inspect JavaScript from the Newspeak object inspector, which is kind of nice. There are, of course, different ways of viewing an object, and we have this configurable system for specifying that. So this is the view for JavaScript objects, but there's a basic view which shows you the actual object implementation, which is not much to look at. It's something you do if you were implementing this stuff and you'd want to look. And this is sort of configurable in a certain way, and in a way reminiscent of what Tudor and company are doing with Glamorous Toolkit, only they're much fancier. We're doing it a slightly different way. They're fancier, but we're more modular, because modularity is Newspeak's thing. So just to show you perhaps another example of that, if we look at source for everything here, here we can look at these icons. And you see, we can show, when we inspect images, JavaScript images come from JavaScript here, but you do get the image. And we can also look at them. Oh, dear. Okay, I knew this would happen in a demo. We managed to crash. Something is wrong. But the nice thing is we can bring it back, and we'll be back where we were. But, you know, this, in case you were wondering, this is not by any means ready for prime time. But you can look at images in different ways, and usually you should be able to look at them. Yeah, now it all seems to be working. So who knows? Something is amiss. But the point being that you can customize how you view images. So I just wanted to show you this as a matter of just giving a brief demo and a sense of how the system looks in the browser. Now the question is, yes, this takes me back to my presentation. So that was our first demo, and I'll do more, but I wanted to simply set the stage with the example that I'll be using in the rest of the demo, and this will give me an excuse to introduce the language and other features. So the expression problem is a well-known sort of example that basically the name and the precise example is sort of due to Phil Wadler. But the issue, it's a languagey sort of example, but it really captures something that is true of programming in a very general way. So we have this language. Its entire grammar is here on this line. It's an expression language. An expression is a number or a sum of two expressions. That's about it. It's a very sophisticated language. It's the smallest thing we could make to illustrate the issue. Now, if you were processing this and you parsed it, you would likely come up with an AST with two kinds of AST nodes, number and sum, which are the rows of this table here. And if you wanted to write, say, an evaluator or a pretty printer, the most obvious sort of natural thing to do is to add methods to these AST nodes, and they are represented here as columns, where each rubric here is the implementation for a given type and function, right? The thing is, experience has shown that while this is the obvious idea, it's problematic. It's problematic essentially for modularity reasons. So if you try and evolve things, it depends how you evolve them. If you decide to add multiplication to your language, well, you'll add a new AST node called product, and you can write that class separately, and everything's hunky-dory, and everyone's happy. If, on the other hand, some nutcase decides to add type checking to a language, I mean, there's not much to type check here, but let's imagine it's a language like Smalltalk, and some loon decides to type check Smalltalk. You know, I know it has happened. And so, you know, then you're going to have to, if you take this approach, you're going to have to modify the code in these classes. And you may not have the source code, or the owner of the original source code may not want you to touch their source code, or at least you have to coordinate through pull requests and what have you. And if they don't let you do it, you can make a copy, and then you have to maintain it and propagate changes. And none of this works very well. And then people in other languages, non-object-oriented languages, come and say, ah, you fool, if you only had structured this by functions, then you could write your type check in a function independently and you wouldn't have to touch anything. But of course, that doesn't solve the problem that if you actually had to do this extension and you had to add this column for type check, now you actually have to invasively modify all of your functions, right? If you had to add product, you have to modify your functions. Each one of them has probably a pattern match or a type case or something which contains the code for each one of these combinations. And so you're going to have the case for product has to be added invasively into the functions. So the function style is good for adding columns. The object style is good for adding classes. And of course, we do know how to handle this. This is what the visitor pattern is for. And the visitor pattern is very nice, and I've been using it for so many years that it feels totally intuitive to me, but it is not obvious to people. It is not the most natural thing that a beginner might do. And so it might be interesting to consider how you might do this differently. So we're going to try and work our way through that, time permitting. And so our next demo, I'm going to run Newspeak right here inside my presentation. So this is not a screenshot. This is a live browser. As we saw, we can put Newspeak widgets inside HTML. So we can, in fact, put the entire IDE inside of HTML. And I'm going to add a class. And as you can see, we have an actual syntax for classes. So this is one thing that's different from most Smalltalks. And the syntax here has a room for declaring instance variables. And they're declared between vertical bars, much as you declare locals or temporaries, right? So it's the same syntax, but these are instance variables, but it's a template. We don't really need that, so we'll get rid of that. And we'll save this. And now it's in my namespace here someplace. Oh, I forgot to name it, so it's named something different. Yeah, let's forget about that. Let's do another one. This one is not going to be named class name here because I was looking for expressions AST. That's the name I want to name this class, and I want it to use to basically implement these AST nodes I was talking about. So we add this, and we go to browse this class. And here's the curious thing. We've got one of these damn object inspectors again. I mean, yes, the class is in here, but we just created a class. How do we have an object? And so this is a new feature that's kind of in progress, which is it sort of works well enough, I think, that I can demo it, but it has also destabilized things as new features are wont to do. But the basic idea here is that, I am too old to simulate programs in my head. And most people aren't very good at it, frankly, right? Computers are much better at simulating computers. So why don't we let them do it? So I basically never want to look at code in an editor and say, what is a plausible value for this variable and what might the code do? I want the computer to show me values and to be able to evaluate things. And this is true even in a very live environment like Smalltalk, right? You can evaluate things only if they depend on globals or class variables, essentially stuff that is static and that is in the image already. But you can't go and evaluate self in a class browser because it's just, it doesn't have a binding for that. And you can't instance variables and parameters and temporaries and none of that stuff, or calling instance methods. You can't do that stuff. It's essentially dead code. And so this is, I'm making an effort to get the environment to do this pervasively, and it's kind of in the middle right now, but we got an instance of expressions AST here. And what I'm going to do with it now is I'm going to add classes to it. And here's where you might ask, what do you mean add classes to it? We're already in a class. But that's the thing that one of Newspeak's big features or key points is that classes nest, right? This is something we got from beta. And so you can do nested classes. And if you are by some unfortunate circumstance familiar with nested classes elsewhere, particularly in Java, please don't think of those. This is not the same thing at all. Those are truly broken. And I know the full sad story there, but this is something different. So we're going to define number. And let's see. And I'll explain what this syntax is in a moment. Okay, everybody can see this?
Yep.
And so what happens here is we're defining a nested class inside an outer class called expressions AST. And when we accept this, we will create this will involve creating a meta class, right? A first class object representing with an instance that represents the class, just as you'd expect in Smalltalk. And but other things will happen. So this meta class will have a method with value. That's basically a class method. And it is going to be, it's called the primary factory method. And it's used to instantiate the class. So when I call number with value with some argument, I will get an instance of number. And it will instantiate it, it will allocate it, and it will initialize it, right? The advantage of this scheme is that you cannot forget to initialize. You cannot get an uninitialized object. And so in this case, the syntax shows you this is where you declare the instance variables, and you can not only declare them, but you can also declare initialization for them. So I got this wrong, didn't I? What I wanted to write was this. And so I've got this instance variable val, and I'm going to set it to the incoming parameter v. All right, this is how I'm going to create my class. And now I have this class, and now I can actually play with it right here. And if I evaluate that, I have a number. Look at the number. It is indeed a number, and its val is 6, as you'd expect. Oh dear, what did I do here? Oh yeah, I know what I did. Darn it. Hang on, we'll recover from this. We are going to go back, and we're going to read this in from somewhere. Somewhere like here, so that we can continue. So now I've actually brought in the entire class that I had saved away, but we have number, and we have also sum in the class. And the other thing I need to tell you about this is that, one of the things I changed from the original version was that I had to make val public. So what happens here is I've declared a variable, and it's an immutable variable. That's what the equal means. And equal is a definitional equality. It's binding it, so the variable cannot change. The object it's pointing to can, of course, it's not a functional language. You can do anything you want to that object, perhaps, but the binding of the variable is fixed. And how do we enforce that? We enforce that by only creating a getter method for it. So remember, everything's a message send. You can't actually reference a variable directly. You can only reference it by sending a message. And so when you declare a variable, we declare a method, val, of the same name, that will actually access it for you. And that method, given that I want to do interesting things with the AST, we will want to make it public. The reason we have this public, there's several reasons, but we have this public and private protected distinction because, again, everything here is a method call. If you think of Smalltalk, methods are always public, and instance variables are always limited to the object. They're protected. Now, if everything's a method all of a sudden, now I can't encapsulate anything, right? Everything's suddenly public. I need to have a way of declaring what is actually part of the public API of the object and what is not. And I do that by essentially marking things public like that. And you can see the green circle here indicates that it's public. So I've done the same thing with sum. It has, again, a factory method, which takes 2 parameters, and it sets 2 fields for its 2 subtrees, which are E1 and E2. And that's basically the AST with no functionality added, right? So this is good and well. And the value of doing this is that we get representation independence. That is, we can change the representation of objects however we want, as long as we preserve their interface, as long as we preserve the procedural interface, the API on the object. And you might say, well, yeah, we can do that in Smalltalk as well, except for your subclasses, right? So you can make it so that anyone using the object has to go through a method and all, and they don't see what your actual representation is. But what about your subclasses? The subclasses can see a representation. They can be written by someone else. In any case, if you change the representation, they might break. And this is not the case here because everything goes through an interface. In fact, even within the class itself, even where we define this, everywhere except that place where we define the instance variables is going through that procedural interface because that's the only thing we can do. We can only send messages. And so we have to go through through an interface. And that is one of the advantages that we get from this insistence that everything is a message send, which credit where credit is due, we got that from self. That's kind of the key, one of the key ideas there. So now let's go back to our example with the expressions and see if we can essentially do this exercise of adding a row to the table. So adding a class, right? How would we do that? So I'm going to open the link in a new tab. And this is, why are we getting this? Doesn't matter. Basically, this means that I had an old version that I hadn't saved, but I can use this and we're back in the IDE. And the reason I wanted to do this way is simply because I wanted to show you that we're serving it from, before we were actually serving it from the Newspeak webpage. Like you go to the Newspeak website, it says right away tells you try it online right now. And if you do that, it opens it again in the at that URL, right? So you can do this publicly, but obviously in the long term, if you're using it, you should be using it locally. And there's several ways to do that. There's a download that gives you a little zip directory that'll set up the thing so you can browse it locally. Anyway, let's go and try and do some more. So we're going to add again all of these guys that are kind of demo classes. And we're going to look at this one. So this is has a nested class called multiply AST. Let's look at that. So multiply AST seems to inherit from expressions AST. That's the class that had the AST nodes, the bare AST nodes with no extra methods except accessors for their representation, for their data. And what it has is one nested class, which is product. And we can see it follows the same pattern. It has a factory method, and it assigns its subtrees just as you'd expect. So this is very much like what we do in a normal object-oriented setting. We just added a class, but the interesting thing is that we are sort of subclassing an entire hierarchy. So expressions AST has within it classes. Classes in Newspeak, as they were in beta, are properties of the object. They are per instance. They are just like instance variables or methods and things like that. They're not some dead static thing that is fixed outside and just sort of stuck inside the class. That's the key distinction compared to Java. And once we do that, we can inherit classes just as we inherit other properties of the object. And so if I look here at, this is product, but we want to look at multiply AST, and I should be able to evaluate sum here. And so sum is in scope, right? I do have a sum object. It is a sum class, actually. And this is the class I had all along, sum from expressions AST, right? Just as I wrote it. So that shows that I actually did inherit from what I was expecting from expressions AST. And I just added a class there so I can extend this independently. But somewhere along the line here, you guys should be asking, didn't you say that there's no such thing as global scope? And if there's no global scope, then you might ask, where does expressions AST actually come from? So we can go back to the outer class, and we'll find that expressions AST is actually stored in a slot in an instance variable. And that is the thing that we are accessing. That is what is providing. We're basically, when we say that multiply AST extends expressions AST, this is the superclass. This is actually a message send. Everything is a message send. Remember that. And it's basically calling the accessor for this slot. And that's where I'm getting this class. Now, I have to do this because since there's no global scope, the only way I can get at anything that isn't defined within the class is and isn't inherited from a superclass is basically by passing in things to the factory method so that I can store them here internally, right? This is the only way this thing can get at the outside world, or any Newspeak top-level class. It can't get at the outside world. It's essentially in a sandbox. The only links to code that it doesn't define itself are passed in as arguments to the factory method. So this basically acts as a sandbox. I can look at this, and I know for a fact that it is not accessing anything else. It isn't like a Java class that has some qualified, fully qualified name that can go and access the file system or the network or what have you. It isn't even like a Smalltalk class that can have globals buried inside it that may be accessing other classes. These are the external dependencies of this class, and I know for a fact there cannot be any others. And they depend on what I gave it, right? It can't reach out and get something it's not supposed to. So this is important for modularity, but even more so, it's important for security, right? This is essentially acting as an import, right? There's no import statement as such. This is just an instance variable declaration, but it gives me the effect of an import, right? This is how I'm getting it. And the way I'd call it, going to make this a little bit smaller so we can see better. Right? If you look here, this is an example of a call that would create expressions with multiply AST. Well, it's still too small, but let's do it again. Hopefully you can still read it for a moment. Right? So I'd call it, I'd call AST class on it to create an instance, and I'd pass the expressions AST class from some scope where I can get at it, like a workspace in the IDE. And that is how I would create it. And this is in fact how I did create, how the IDE created the exemplar for this guy, which is live and functional as well. So the point of all this is that this is good not only for modularity, but it's also good for security, because the sandbox really limits what this code can do, and it can't go and do damage. So if you look at this, this is what we said. Remember the buzzword that says object capability language? This is the object capability model, which is due to Mark Miller and his classic PhD thesis with the language E, which I said was an important influence on us. And it turns out that if you do modularity right, you get object capabilities in an object language. You get capabilities anyway, because the requirements of the object capability model are pretty much the same. It says that you don't have authority to do anything to the outside world unless you have an object that can do it. Either an object that can directly do it by calling a method, or an object that could give you another object transitively that might be able to do it, and so forth. And so basically, if you can reach an object that can do something, you can do it. And if you can't, you don't have a path to that object, you don't have a series of pointers basically given to you from the outside, you can't do it. And you can't rely on static state, because that would be a problem, because something could be left in some variable that anyone, that could be shared and people can access. So you can't have static state. We do not have static state. We don't have class variables, for example, in the same sense that Smalltalk does. We only have instance variables, possibly of the enclosing class, but they're all instance variables. And ambient authority means there's no global scope. There's no place where you can just say, I'll just name something like, the file class in Java, and I can get it files, whatever. No, everything has to be restricted this way. And to enforce this, of course, you need the access control, because otherwise the objects are exposing their internals and all is lost. So this is kind of our security story, and that's why we're an object capability language. So at this point, we've done the easy stuff. It might be interesting to add columns. And to do that,
Gilad, do you allow questions in between? Or would you rather just present?
We can have questions as long as they don't get out of hand, because then we'll never get to the end. And let's see, how we've been going, what, 40 minutes out?
40-ish.
Yeah. So we're in good shape still. So yeah, we can have
Ron, do you want to ask a question?
Yeah, it's just a quick question. So the scope of the class that you passed in, is it a copy, or if you needed to make changes to it, would you have to rerun the factory method? Is it a pointer or a copy?
It is a pointer. You would you pass the class in, and you are subclassing it. And so it is a reference to that same class. In this case, it was literally a class object, not necessarily an instance.
But, so you could actually make changes to that class and affect your instance then.
For that, you would need to change that class. You would need to the class would need to have an API allowing you to change it. Classes generally don't have state in Newspeak, and otherwise you would have to change it using reflection, which would mean that you would have had to access mirrors to do that, and that again would have to be passed in from the outside.
I see. Okay.
So, but normally you would import the class or what passes for an import, so that you could subclass and make the changes you wanted to your subclass that has no effect on the imported class.
Correct. Okay. That's a good question, and it clarifies things. So now there's one more mode that we can run Newspeak in. So we've run it on a shared page on the internet, which you can go to the website. We've run it on a local host. We've run it inside the presentation itself. What I want to do, oops, that's not what I wanted to do. I want to get this out of the way a bit and find a Finder window. and find applications. And there's one more way to run this, which is as we build it as an Electron app. So you can actually run this thing, and now Electron is this thing that basically uses Chromium, the source code for Chrome, but not as a browser, but is designed to let you run it as a local app. And this is what this is. So we can run here. And we can, again, load our stuff back from wherever it was. And now we want to add essentially a column, right? We want to add functionality, a new function. So we had the bare AST. We showed you how we can add a row that is a new class that still doesn't have anything. But what if I want to add the equivalent of columns? So I want to extend this to add an evaluator, just as I would say with a visitor. But I'm not going to use a visitor. That's obvious. The whole point here is that we can do something different. So here's this class. And again, it has a nested class evaluator. And evaluator, again, extends expression AST. And inside it has, again, those two classes, number and sum. Let's look at them. So number, oops, I clicked on the wrong thing, this guy. So number seems to be very similar, but look at its superclass clause. It's super number. What happens here is we would have inherited number from the superclass, but instead we're overriding it, because this class number is the same name, and it's going to override the number from the superclass, but we're defining it such that it extends the original class, right? That's what super number here is, right? Again, it's a message send. We're getting the number from the superclass. If you want to think of this sort of operationally, every class, every nested class you define gets a getter method, right? Again, we cannot reference the class directly, just like we couldn't reference a variable directly. We get a accessor method that we can send to get at it. And so essentially, this one will introduce an accessor method that overrides the accessor method that would have been inherited. And we actually use the inherited one by calling super. And that way we're going to get this class that is an extension of the original, number class that we had, the bare AST. And interesting, you can see it has the instance variable val, and it even has a value, number 2, which comes from this comment right here. And I may explain how exemplars work. Basically, these are metadata comments. The mirror system understands them to some degree, and they give me the information I need to figure out how to instantiate a class, so I can provide you with a live instance whenever you're viewing the class, right? And so this one got set up with a value of 2. That's why val is 2 here. And the eval method is what you'd expect for the simple case. All evaluating a number AST is just a matter of giving you that value, and we can evaluate that, and it comes to 2 as you'd expect. Again, we can evaluate things live in the method instance method code, which is kind of nice. And that is basically how we have added eval without invasively. We've added a function without invasively changing the original AST class, right? By essentially defining a subclass, then we're extending the whole hierarchy. We're doing the same trick with sum. Right here. Sum has, again, it's calling super sum. This syntax means we're passing those same parameters up the class change for initialization, just as a sort of conventional constructor would. And sum was created, again, with this expression, so it has the two subtrees, a number with 10 and a number with 6. And if we look at eval, it does what you might expect. It evals the first tree and then the second tree and adds them. And if I evaluate that, it's 16, which is 10 plus 6, as you'd expect. So in a sense, we've added the column that was missing. And we can do this, so we can add columns and rows independently, or parts of columns and rows independently. If we were to go to, which guy? I think it's this guy. So this is a case where we look at the nested class, it is, again, extending the AST. In all these cases, the AST is imported in the same way, the original expression's AST. And it is extending product with an evaluation. So here's product, and it's extending super product. So whatever AST class we have here had better have product in it, right? So it isn't the original AST, it's going to be the extended AST that we already added product to. And there's an eval method which does the product just as you'd expect. And the way we got an instance of this whole thing is here, right? So here's a more complicated expression that is used to set up the whole structure such that I get this thing with a already extended case of AST. So if we quickly go through this, this expressions with multiply is the guy that adds product. So we created an expressions with multiply instance. We got its multiply AST, which is an AST class, which already has node, the nodes for number, sum, and product, which it got from multiply AST. We used that to create the evaluator. So that added eval methods for number and sum, but it didn't touch product because it didn't know about product. It was developed independently. And this guy is just adding the last rubric, which is the eval method for product right here by taking that evaluator and subclassing it again. And this is sort of a pattern of inheriting whole class hierarchies so that we can do this. And we've still kept the sort of obvious natural model where all the methods are in the AST nodes. They're not in some external fancy pattern that you have to know. So that is kind of the core thing I wanted to show you. Exit full screen, right? And we can go back to our presentation. And there's plenty more to show, but I don't want to take up too much time, and there may be questions at the end, etc. So I'll just tell you basically how this works. This is a bytecode interpreter and VM written in C that Ryan Mackinac, who may or may not be in the audience, I don't know, I noticed he registered, but I don't know if he ever showed up. He wrote for us, and it's compiled to WASM, and that's the engine that's driving this. We also have a Newspeak to JavaScript compiler, and I say its status is uncertain because basically it had pros and cons. The pro is it actually performs much better. The con is that it's very hard to get the proper semantics, and very hard you should read as impossible. JavaScript is evolving, and based on some of the latest changes, I have this idea that maybe we could eventually make it work properly, but it was really hard next to impossible to get it to do an effective and clean job of doing the proper semantics. So it's nice to have this engine here. So there's, as you can see, we had a crash during the demo, and sadly that is not that unusual. We still have a lot of work to do to debug the reactive UI to improve the performance, because if you use the system too long, it starts to act up. To clean up, to add functionality like the full hypertext editing, source code integration, orthogonal persistence. There's a laundry list that should keep my weekends busy for years to come. I wanted to thank some of the people who worked on this. So the first list is people who have at some stage or another been paid to work on Newspeak, mostly the original Newspeak team when we actually had funding. Plus a few people who got to be interns at various stages. And then there's the volunteers. You'll notice that Ryan's name appears on both lists because Ryan has done a ton of work on his own time, enormous amounts of work over years to get us to where we are today. A bunch of other people have done more or less. Some people did master's theses. Some people did just a little bug fix. Other people have done more substantial things. But we really, really need a lot more in the way of volunteers. I'll also thank the people who did our graphics, my wife, Victoria, who designed Big Brother's eye for me, and Hila Achmian, who did the Double Plus Good logo that we saw in the beginning. And that is the presentation as such. We can answer questions if there are any, or demo more stuff. But this is pretty much kept us going for the better part of the hour, and I don't want to take up too much more of people's time.
Thank you. Has your team done a window system for Newspeak on the web, like with CSS or Canvas graphics?
Yeah, my team. That is a work. My team is a work of fiction. This is a labor of love, and there is no team. There was a team once upon a time, long before we did the JavaScript version. But yes, so where are we? I should make this smaller so I can see where I am. Let's see. So maybe we'll do it here. Hopscotch here. Maybe you're thinking of, is this it? Hello, yes. I'll make this bigger a bit. And I'll make this smaller so we can see. So this is a GUI library, right? So all the GUI here is none of it is written directly to the DOM. You can do that. You can call to JavaScript and you can write to the DOM. And if you enjoy that sort of thing, more power to you. It'll probably perform a lot better. But my whole point with Newspeak is to pave over all the ugliness. If I wanted to use the DOM, then I could use TypeScript or something, right? So I want to pave over not only the ugliness in the language, but the ugliness of the whole awful system. But you can write these UIs, and I have a video like on the Newspeak site of doing like a small to-do MVC or a counter or something like that, which uses this system. So it's basically, you can see there's things like fragments for different things, decorators, columns, CodeMirror wraps CodeMirror so we get an editor because that's too much work, buttons, etc. So there is this entire thing that essentially gives us a library that can be used as an internal DSL to create UI. So in fact, we can show this. If we do inspect presenter, this is a class presenter, right? That showed us what classes are like, and there'll be a method here like definition. And this is what defines the UI for this thing. It's a column, and it has a help section on top, and the heading, and then it has the nested classes presenter for all the nested classes, and the instance methods, and the class methods. And each of these is, again, calling a method to give it a subtree, basically fragments, which are, you can think of it as something like virtual DOM, right? Widgets that describe the hierarchy, but aren't actually the display thing with all the coordinates and all the mess. And those, the system eventually translates into DOM nodes, which is what gets displayed. So I think that's the long answer to your question is yes.
Well, I was also wondering if you had like some free-form graphical capability.
Hang on a second. Yeah, so, well, you can write to Canvas, and you can, hang on, let me find, this is not a question that I anticipated, but we do have something. So if we go back to here, let's go back to the Newspeak page, to demos. Here, like particles, I think. Is this something like what you had in mind?
Yeah.
Yeah. So this, I believe, particles is writing to Canvas sort of directly. I forget how it works, but we do have there's this sort of lower level, like the fragments. You know, can do you can do shapes and things with them, I guess, but mostly the system is designed to deal with the higher level and leverage off the DOM and integrate with the DOM. It's
right.
Yeah. Any other questions?
So going back to the expression example, so you got these AST nodes and different node types, like sum and product, or just different classes in your traditional Smalltalk format. But to extend functionality rather than doing different types of visitors, it seems like you've got the entire class hierarchy of AST nodes within an outer class. You're using this outer inner class I guess, from Beta that I'm entirely unfamiliar with to allow you to extend that functional comb. Is that correct?
That is correct. Now this is not the only thing you do with nested classes, but it is a nice example of the fact that we can inherit entire class hierarchies and do this is something we get. But generally, remember, the top level class is a sandbox, so it's our modularity construct. An instance of a top level class is a module, and you typically have nested classes in it. So let's find something else that's in this style. Let's say here, collections, right? So collections is something you can imagine. I'll make this bigger again. And you can see that it has things like list and map, which is ordered collection and dictionary in Smalltalk speak.
So to the instance variables of the nested class, at least in this usage, take the place of what would be like global variables to access classes in traditional Smalltalk.
In a way, yes. Well, essentially, you're calling methods to access them. Essentially,
I mean, you're still calling methods. Yeah.
So the classes you declare here, the syntax lets you declare a class. Yes, the implementation does hold them in an instance variable under the cover, and sometimes you're doing explicit things. For example, this thing is for various sort of reasons, basically because we wanted array to be tied to the collection interface and arrays in kernel. So collection itself is defined elsewhere, and it's being imported. So it's held here. The copy of the reference to collection is held in an instance variable. But the others are just declared as classes. And yes, the implementation holds them in an instance variable, but you don't see that.
Okay.
Right? And it doesn't really matter whether it's an instance variable or not, because you don't care. You're accessing it via method, and you could have a method that computed it on the fly.
Well, yeah. But if you're just doing the traditional like namespacey thing, it would just be a getter on the outer class's instance variable that gives you the kind of list you want.
Yeah. So you can do a traditional namespace thing. You do get the semantics of scoping that the language has, which means that things, the nested namespace, you can make everything in them public or not, but if you don't, then they won't be accessible to the outer namespace and so forth. But yeah, this behaves like lexical scoping, but strictly speaking, it isn't lexical scoping because it's all a product of the lookup rules. It's all dynamic method lookup, but you can't tell the difference. It behaves exactly like lexical scoping until you start looking at inheritance and stuff, and the rules are slightly more involved. But yeah, these things are nested, and they can see their siblings, and they can see what's around them, but they cannot see what's inside the internals of things that are nested inside them.
Can you speak just for a minute about because I'm unfamiliar with Beta, the lookup semantics you get with nested classes as opposed to inheritance?
Okay, so Beta, this is a little different than Beta. Beta is a thing of beauty in its own right. And
I don't know Beta at all, so
yeah, well, sadly, it is not well known. But in Beta, just to say a few words, Beta unifies functions, methods, procedures, classes, types. All of those things are one thing in Beta called a pattern. And once you do that, interesting things happen, because obviously you need at least methods within your classes, right? So once they're both patterns, then patterns nest in patterns, and that means you get classes nested in classes, and you get classes nested in functions, and every combination of this, it just composes. And you can argue whether that's actually too uniform in general, because it tends to confuse nouns and verbs. But Beta is a significantly more static language than Smalltalk or Newspeak. So in Beta, these are actually lexical scoping rules of a sort. But in Newspeak, it's all handled by the method lookup rules, which basically, they do what you want. They're a little tricky to implement, but what happens is, depending on the syntactic form, but for the lexical scoping, you look up the surrounding enclosing object hierarchy, which is essentially the lexical scope. And if you don't find anything, you send the message to self. That's sort of the short story here. And so
once it goes to self, it follows the traditional superclass.
Yes, once it goes to self, it follows the superclass modulo, of course, the fact that there's access control. So it goes to self, and it can look at private stuff in self and protected stuff up the chain, but not private stuff. So there are some subtleties due to access control. to
Cool.
basically make sure. But yeah, it basically it does the lookup chain, but it gives priority to lexical scoping, which is exactly the opposite than, say, Java or Beta for that matter, because that leads to better modularity in essence, less chance of you breaking something by changing stuff in a superclass. Was that
Thank you.
somewhat clear? Yeah.
Yes, although I'm glad this is being recorded.
Yeah, well, there's lots of material on this. There's a paper. There's there is more stuff for anyone who really wants to get into the nitty gritty. The essence of this is that because it behaves a lot like lexical scoping, mostly you don't need to know, unless you're trying to write tricky test cases like people like me do. You don't need to know exactly the details of the lookup algorithm, which is described in a paper and everything. It kind of does what you want. And making it dynamic as opposed to Beta turned out to simplify things a lot, by the way. It's kind of interesting. There's a old paper which Beta explains its semantics, and it's a whole paper to explain what goes on there. And it's about 10 lines to actually do the dynamic lookup. So dynamism is always better.
I have a question, which is, it begins with, I'm delighted that you've worked in capabilities the way you have. And have you done any sort of examples of where that's, something really, how you made something solid that wasn't before? And I mean, I think that's something that a lot of languages are missing, and a few have done a decent job there. And looking forward 10 or 20 years, I can't imagine that there will be any other things left.
Well, so the thing is, again, this is a hobby, and we haven't had the resources to actually build a lot beyond the what we use, the IDE itself.
Mm-hmm.
The model sort of object capabilities almost fell out into our hands once we decided on modularity.
Mm-hmm.
And the thing is, to make this stick, to make this actually a secure system, well, this is one of the reasons we had to get off of Smalltalk, because as long as you're in Smalltalk, Smalltalk can do anything it wants to you, right?
Yeah.
And it's very hard to secure a Smalltalk system because it's all about openness, and essentially, if you're not careful with reflection, right? Any Smalltalk code can go do all instances, find all the classes, then change them. The wonderful power of the system means that it's really hard to nail down for security.
Right.
Right. But here we, running on the web, we sort of still are somewhat dependent, but in WASM, we're fairly well isolated even from JavaScript.
Yeah.
And the thing is, to really make it secure, you have to do a review and make sure that your APIs are not accidentally, even though there are capabilities, they're not letting something in or out that they shouldn't, right? You can still screw this up.
Right.
The people who are doing this seriously, Mark Miller is doing this for JavaScript, for sort of a limited subset of JavaScript, and doing a very thorough job, and they have a startup and all this kind of thing. And that's a bit different. So I wouldn't say the system is secure. There are holes here because of the way certain things are implemented that I have to fix. But so I can't make claims for this actual system that we've built being secure yet. That there's a lot of just work, right? We have this foundation that guarantees that you can make it secure, which is very hard to do in other systems.
Right.
But we don't. This is even less mature than the Smalltalk system was, right? In a lot of ways, it's just a lot of work, and nobody's being paid to do this. So it goes depending how much free time I have and a few others who contribute here and there. It's hard. We need volunteers, honestly.
Maybe you'll gather some today.
Maybe I'll gather some today. You never know. I hope so.
I like that your answer begins with modularity, because I remember my favorite quote is that security is just extreme modularity.
Yeah, that is true. I mean, once you do the modularity right, it falls out.
Yeah.
It is essentially the same thing in a way. It has to be an object capability language. If you do objects and you're doing, you can sort of do this model of modularity, sort of in a functional style. But you won't get far without something that smells like objects, like records or something to name things. So it is modularity is the chief thing here, and it does give you, all these nice properties, and it's a wonderful fit with objects, right? I hold that I am just continuing the core idea, because an object, the thing about objects is not inheritance. The thing about objects is an interface that encapsulates things, and you can only get things through a method call.
Yep.
And that is the heart of it. Once you do that everywhere, then you get the modularity and you get the security. It's just a natural fit.
So speaking of the security in E, do you have sealers?
Sealers are a pattern, right?
Okay.
And you can. I'm trying to remember exactly what that was, but see, the thing that's different from E is that E relies heavily on closures, as does the JavaScript sort of secure dialect, on closures to actually encapsulate things, right? And here we're actually going with objects. You don't have to do these games with closures, because closures are the only thing that you can protect in JavaScript, or for that matter in E, right? Whereas here, we have objects, and the objects, the privacy of objects, again, this is not some static analysis garbage, right? This is intrinsic to the engine, right? The context-free syntax tells you what kind of access this message has, and that gets translated to a bytecode that implements a lookup that only finds the thing it's allowed to access. So it's intrinsically in the system, and you can just declare something's public, something's not, right? So it's actually simpler in that way.
Lee has a question. He asks in the text chat, how is this similar or different from Lively? Are there classes for interacting with the outside world, such as files and networking and REST?
Yes. So I've shown you multiple times loading files. So it's in there somewhere. Let's see if I can find it. Web files, I think it's called. Okay, so this is web files. And this is basically leaning on the JavaScript, right? So here, like, let's look. I think most of the work happens here in this method. So, JavaScript's, the browser's APIs for files, there's all this stuff with blobs and what have you. And so basically, you have to create this kind of, what do they call them, internal URLs or something like that. And so document, that's the web browser document, which we've imported, and we're calling a JavaScript method create element, right? Except we're calling it with Newspeak syntax, and then we get this essentially link, this DOM node, download link, and again we do a bunch of things to it. We set the style. We're basically setting up all this JavaScript stuff to create the link, and then eventually we can, once we have that URL for a file, then it will fetches the file, right? So there is this is kind of typical of the style of interacting with JavaScript. It all goes through aliens, so you have to actually get at these things. Let's see how it does that. So, right, platform, it's getting platform as a parameter. Platform is an object that basically encapsulates the entire platform. As we said, we're doing whole libraries as classes with nested classes within them. That's nice. We can have multiple instances of libraries. We can save them, serialize them, pass them around. All that stuff happens naturally. So platform.js, platform has a method that gives you access to the JavaScript, and JavaScript, the JavaScript object gives you a global namespace, global. That's essentially the window. We then look up the document. We can get the object class, just as we did the DOM parser by looking it up, the array class, because this wants a JavaScript array as an argument, et cetera, et cetera. And we have a bit of an issue currently with automatically doing that from Newspeak arrays to JavaScript arrays, which we'll probably solve someday. So this is kind of, you can see this is kind of the code that you write to actually interact with JavaScript. I'm not sure if that answered the question, but ask again if it didn't.
Yeah, thanks, Lee. And Yoshiki has a question.
Yes, am I on?
Hi.
Yes. So I'm, so to speak, I am still curious about the transparency onto JavaScript route. And you mentioned that it could be faster, but sort of it's impossible.
It's faster. It's embarrassingly faster. I'm sorry to say.
I take that it's if you try to map the semantics to like JavaScript prototype chain, you can get into trouble. But you sort of want to do it as much as possible, but not any more than that. And I'm curious if there is a actual sweet spot somewhere.
So the current JavaScript transpiler is the third generation of that we've done. I wrote the first one 2010 or so, because it was always part of the plan to do this in the web. When we started the project in late 2006, the web was not where it was today, but I knew that it would get there because they just hired Lars to work at Google, and he couldn't say what he was working on, but it was obvious what he was working on. And so I knew that there would be a fast JavaScript, and we wanted to do that. We finally got around to it, and that compiler didn't perform very well. Nothing I write ever performs very well. I'm more interested in making things sort of nice, and I need people to actually do the hard work. So anyway, Vasily reworked that, and then eventually Ryan reworked it again, and it still doesn't perform as well as JavaScript, but it performs pretty damn well as long as it's doing what it can, and it can't do a lot of stuff. So it's very hard to think of things like all instances. In fact, I gave a presentation at a conference a few months back about these problems. So how do you do all instances in JavaScript? And therefore, how do you do atomically install changes, schema changes to something, and become and things? Either it's incomplete or inefficient or hard, or it's a bloody mess. And because I'm talking about transpiling to JavaScript, right? Sticking with we're not doing a VM on top of JavaScript. This is a VM, or Squeak.js is a VM on top of JavaScript. But the effort we did was actually compiling into JavaScript. And that has lots of problems. I mean, now you can finally do integers. We couldn't even do integers right? Because that language didn't have integers. I've commented on that elsewhere, what I think of some of these designs. So I won't be on my bad behavior today.
JavaScript sucks, man.
Yeah. So there's all these things that are really, really hard to do. Now, there have been changes recently that give me hope that you might be able to do something probably not as efficient as the current transpiler, but more efficient than having an interpreter, on top of WASM. Because WASM isn't terribly good with interpreters, and you can't really do a JIT, and so it's kind of limited. But you can do things. I mean, I'm actually thinking that you could do something with an object table in JavaScript, and it might still be considerably faster than this. But it's a lot of work, and who knows when we'll do it. It depends how things go. There's one more thing I wanted to mention, because the question originally, the previous question, I talked about two things. So I answered one of them, which is how do you talk to files, etc. But how does it compare with Lively? Well, it's a very different thing. For example, we do not do morphic. We're actually just talking to the DOM, right? So we're much more of a conventional kind of thing. You can, of course, write to Canvas and do whatever you want, but we're basically working with the DOM, which is not the worst thing. The DOM is a lot better, for all its horrors, than most other mainstream UI packages, which wouldn't let you do the kind of things that we're doing. So that's another big difference. And of course, we're not doing JavaScript. We're doing a different language. So if there are more questions, I'm not watching the whole chat thing because I'm keeping this open in case there's something I need to show again. So I'm keeping the screen share and everything, but I don't know if there are any more questions or we're done or what.
I don't see any more in the chat right now. And this is usually when we throw things open for just open discussion. But does anyone else have a question?
Well, this is more like just a vague general one. But, there's various languages, particularly at class, that, try to handle polymorphism in a more uniform fashion. And, although I appreciate the design of using nested classes for, I guess, the columns of the expression problem, and traditional Smalltalk creating new classes for the rows. I'm I'm a little weirded out by having like one dimension be a completely different mechanism than the other.
It always is a completely different mechanism. Methods and classes. I mean, one dimension in Smalltalk is a completely different mechanism, right? It's just methods.
Oh yeah. I mean, Smalltalk took everything which no one had to do more than one and said, we'll just do one right.
Right. So, by the way, it is the same mechanism because essentially one of the things that keeps us sane and keeps implementation not too complicated is ultimately everything's a message sent, right? We don't actually care if it's a class or a instance variable or a method. So, and therefore the lookup rules are exactly the same. The VM only does, lookup of methods. It doesn't actually care about all this other stuff.
So the base lookup method at the VM level is your traditional single inheritance.
Absolutely not. No, it is not your traditional single inheritance. First of all, one of the things I didn't emphasize, which sort of follows through from this, is we get mix-ins for free, right? Because of late binding of superclasses, we can essentially bind a class to different superclasses, right? So you can declare a nested class to inherit from something, and then you can override that in a subclass, or set it to be something different, and that subclass, that same body of class, will now inherit for something else. So it basically has to work as a mix-in. So
if I send a message to an object and that class doesn't directly implement it, it's got to like go look up its inheritance methods.
Sure.
Is it actually invoking Newspeak code when I say what's the superclass to search for next, or is that baked into the VM?
No, there are. So unlike Smalltalk, where there's basically one, you can think of one sort of send a bytecode potentially. There are different ones because different syntactic forms give you basically different things. So a public sends, you have an object like one of these things, right? We have an object, we're sending it the message global. That is one thing, and that is different from the lexical scoping kind of mechanism. So a public send is the thing that's most similar to your traditional Smalltalk go up the hierarchy. The only thing is, of course, the VM is doing this and only looking for public methods, so it will skip over anything that isn't public. On the other hand, if you are doing something inside a class and referencing the lexical scope, there's this more complicated process. All of these are essentially built into the VM. So there are multiple lookups with slightly different behaviors depending, because they have different rules of what they can access and also where they're looking. So this all happening at the sort of base level of the VM. In that sense, that's what I'm saying. It is not just your traditional lookup.
Okay.
But the other thing I'd say is that I may have I wanted to show this class hierarchy inheritance thing, but nested classes have a lot more uses than that. The hierarchy is a universal thing, and it really has a lot of other applications beyond this particular pattern of doing the expression problem and similar things. So first of all, it lets us package things into modules by hierarchy, and then have first class modules that we can pass around and have the sandboxing and things like that, essentially namespaces. There are nice patterns you can use. I don't have time to get into how Vasily designed our unit testing framework, which is definitely not an S-unit clone, and it leverages the hierarchy there as well. So there's different places where you do it. The whole modularity thing is what gives us a nice deployment story that I haven't talked about, because it's much easier to disentangle your code from the environment in Newspeak because it's modular. Right, so we can actually deploy applications that are completely separate from the IDE without going through heroics. It's one of the advantages of having a truly modular structure. So nested classes, there's a lot more to them than just this pattern, is what I'm trying to say.
So can you use nested classes to sort of like be like ML style modules where you instantiate it to do the dependency injection kind of thing?
We do that. We do that, except we do it right. So essentially, if you look at this, this is, I hate the term dependency injection. Basically, you can view Newspeak as either new dependency injection is built into the language, which is what some people say, or we obviate the need for dependency injection because you don't need to do all that mess.
Well, that's why I said that kind of thing. I mean, the kind of problems you solve with that.
Right. So this is similar to ML modules in the sense that we are passing in parameters that are essentially configuring this like an ML functor, right? The difference is that ML functors come with all kinds of limitations because of the type system. So ML functors cannot be recursive or mutually recursive. ML functors are not first-class values. There's a bunch of stuff, and there's fascinating papers, and Andreas wrote very complicated, very clever things to work around this stuff. But in reality, the stuff is, there's also a paper by Harper and Pierce in Benjamin's book that discusses why they sort of don't recommend full functorization anymore because it didn't work for them. It works for us, partly because we don't, we're not type checking it. I do know how to type check it, and it would be very different, but it's not a priority. But we'd never get to this design if we were worried about types. It would sort of give us blinders, as it were. So essentially, every time you create a module, you are configuring from the outside. You can think of this as a ML functor, except without the limitations.
I mean, you don't have to comply with the type checker. You would basically define, I don't know what you call the top level thing you start at, platform. I saw primordial soup. But there's something, I mean, you have to be given something to be able to send message to before you can start.
Right. So that actually is extra linguistic, right? So the language does not have a top level scope. What you do have is a tool, the IDE, where you can load things in, and the IDE. So if we look at like workspaces, for example, right? What workspaces do, they let me access all kinds of stuff, right? So I can get platform here. Right, so essentially, I'm in a I'm in a sort of a global namespace, but this is not part of the language. This is something the IDE is setting up. Basically, workspace has a does not understand that looks things up in the namespace of the IDE, right? And that lets me actually play with things, and there I can configure things and put them together. But once they're running as Newspeak programs, they don't have that access. It's all capability based.
So like, just to give me an idea of the top level, is platform there a message you're sending to some implicit receiver?
Yep.
And the receiver is what?
The receiver is this instance of workspace right here.
Oh, okay.
And what it does, okay, so workspace, let's see, workspace is, let's go to workspace manager and find this. So workspace is a subclass. Each workspace you create will be a new subclass of workspace. This is where the real work is. And I think, okay, something may have gone wrong here because, yeah, so it's slow. It occasionally slows down for mysterious reasons, but here we are. So workspace has a few of the convenient ones are just here, actors, aliens, etc. But there's a does not understand. And goes to root. Root is the namespace of the IDE that is in, someone, we define it someplace, probably in workspace manager in the surrounding scope. And we do a lookup for that thing. And if all else fails, we tell you does not understand. But that's basically how it's figuring this out, right? Platform is actually here, right here. And again, we save that in the surrounding scope in the workspace manager. And so, yes, they're all messages that we basically use this class to construct what appears to be a global namespace so you can conveniently play and work and configure things.
Well, I must say, I do love working inside of a workspace. So that's cool.
Well, so we're trying to make everything a workspace, right? So basically, the workspace is just an object inspector on this object that has this behavior. And we're trying, as I said, with the exemplars, the system is by no means complete yet, but we're trying to get it so that you always have something live to work with. There is an issue really with Newspeak. This modularity means that sometimes it's just a pain, right? That you can't get at something. And again, in the programming environment, in the Smalltalk environment, we had an escape mechanism. At some point, we called it black market. which let us, in development, saying the debugger, let me access things anyway, just so I can get at something because I forgot to import it while I was developing, and now I realize I need it, and so forth. But that doesn't actually, that's one of the things I need to add to the ID here for the web ID. So sometimes it's certainly a discipline, right? One thing is very hard and very tricky to keep all this structure and modularity without losing the kind of feel you get in Smalltalk of the freedom that, there's a trade-off there.
Cool.
Thank you.
I also like the exemplars.
Sorry?
I also love the idea of exemplar. Like you said, you're in a class browser, and self isn't bound. Of course, in traditional Smalltalks, it's bound to class, which is completely useless because all the code you're looking at is instance code.
Right. Yeah. So the point is you need the data from somewhere, and I tried to do clever things in the past. I mean, my first demo of exemplars was in 2012. But it was, again, just a demo, and to do it systematically, I tried to let's try and infer it and find it. Eventually I said, what the hell, all we need to do is just give me some metadata, tell me how you expect this thing to be instantiated. Now you do have to work out scoping rules for this metadata, where is it being evaluated, etc. And there's the mirrors, the reflective system. You don't have to parse this yourself. The mirror system can find you the metadata. It doesn't understand the metadata, but it can give you nice, convenient access to it. So there are a few pieces that needed to come in. But basically, once you have that, and there are tricky situations of various things that arise. I'm still working on this. This is really recent, but as you can see, when it works, it's really nice to have.
Oh, definitely looks cool.
Thanks, Gilad.
Definitely looks cool.
Thank you. So, as they say in The Simpsons, are we there yet?
Yeah, I think we're there. Thanks, everyone. We're going to keep the meeting open until the top of the hour just for more conversation, but this is sort of the end of the official part of the program. And I'd like to inject, to use that word, one more quick announcement. There'll be a special gathering to celebrate Squeak's 25th birthday on Friday the 24th and lasting all weekend right here at this place here on 8x8. And I'll also put a link in the text chat to a little blog post I wrote about it. So with that, if you need to go, please feel free, or feel free to stay and chat some more. And thanks again.
Yeah, thanks so much, Gilad.
Okay, so I'm going to stop sharing this on the assumption that no one wants to see the system anymore. Did that work?
Yeah.
Yep.
Okay.
We see you again.
You see, well, that's your misfortune, but yeah.
Looks like it got dark by you.
Yeah, the sun went down.
Yeah, it's quite dark. I guess I figured when you're watching the screen, it doesn't matter. And when you're watching me, it matters even less. Yeah, so anyone who's interested, there's a website, easy to find on the web, and if anyone actually wants to do anything about this, it would be great, because it is progressing very slowly.
You ever think the whole George Orwell thing is just scaring people away?
Nah. I think that the fact that it's nice scares people away. Honestly, that's my.
This is the future. A type system stomping on your face forever.
Yeah. Well, we one of the things I haven't done, which I have a plan, is an optional type system. There actually is a syntax for type annotations.
I did see the angle brackets around a few parameters there.
Right. So whoever remembers Strongtalk, that's the Strongtalk syntax for types, and we do support it. Though we might, if once the metadata is mature, we could stop doing that and just put it as metadata. But they're just decorations, right? I have to actually implement a type checker, and it's much harder for Newspeak than it was for Smalltalk because of this modularity thing. But I do have a scheme. I do know how I would do it, but it's got its proper priority, which is at the bottom.
Well, I do like your fundamental principle that type annotations could not change the semantics.
Yeah,
Only reject programs.
You need to be the temptation to do that. I've seen it in so many language projects. It's almost impossible to stop it unless you start with a dynamic language and have it established. Like TypeScript is doing well because again, those guys, JavaScript is out there and they had no choice. And in a sense, when we started Strongtalk, we also had no choice because we started that before we had the VM, and we could not actually do the wrong thing. So that helped. So did I remember hear correctly that someone was working on Strongtalk to do something with it?
Yes, George Cox said that he's working on. He's here.
He's here. Okay, awesome. Yeah, if you're still alive at this hour in London, yeah, tell me about it.
I just saw him.
Oh, you're muted, George.
Maybe hardware muted also.
Okay, research project, technology.
I just saw his camera too. But he's there. I just saw him mute and unmute.
I'm going to drop out. Thank you so much again, Gilad. And we should repeat our call for more talks because we have slots. So, but I'll begin. Bye, everyone.
See you.
Can you hear me now?
Yes.
Yeah.
Perfect. Sorry about that. KDE is playing silly buggers. Yeah. Well, first of all, I'd just like to say it is a great pleasure to be amongst such dealers of lightning as you gentlemen. It's been I'm far more USB than PhD. This really has become a dive into Lisp and Smalltalk has been kind of a midlife crisis research project for me after doing because when I did computer science at uni, we didn't really study Lisp or Smalltalk. Anyway, getting in to answer your question, Gilad, I actually decided to get back into C++ at C++ 20, and then through other sort of things, basically actually watching Yoshi's archive of Alan Kay talks, I kind of realized that there was the Smalltalk rabbit hole was definitely worth going down. And then I came across Strongtalk through whatever means, and then I had this lunatic idea, given that the date was 2020 and C++ was 2020, that maybe we could have a Strongtalk 2020 by sort of bringing the C++ up to date, which I have sort of managed to do here and there with const expressions and what have you. Right now, I'd love to show you a demo of it, but due to tagged pointers and 32-bitness and me buggering up sign bits, it runs, but it crashes immediately. I have had it actually running up to date. The goal is to, obviously get it up into 64-bit at some point. Maybe replace the.
That's not easy.
With it. No, absolutely not. And parts of it to. I only sort of mention that because the strategy for doing that would be not necessarily to rewrite the assembler stuff, but to import maybe ASMJIT or some other part. Like, for example, Gilad will probably remember the horror that is include DB, and I spent many a happy hour getting that out of the way so that and preening down the include so that it compiles nicely. Yeah, long story short, I'm working on it at the C++ level. It's actually a Win32 project in disguise, because there is, for those who don't know it, you have the VM binary and you have the image file, of course, and the image file contains the Win32 image file contains calls to Win32 calls through the FFI, the DLL business. And there's Stephen Reese has done some attempt to get it working on Linux. I tried to get in touch with him, but he didn't answer my email. So maybe he was scarred too badly. I don't know. But right now it's running under, when it is running, it runs under Wine. And yeah, it's not too shabby. But really, so most of my work at the beginning has been to try and keep the main structure of the code there. Replace things like the logging with things like Speedy Log and kind of modern day C++ things. It's on my GitHub actually. Let me just give you the link in the chat. It is a bit broken right here, right now, for which I apologize profusely. But yeah, I hope you like the name Strongtalk 2020.
That's a fine name. Yeah, awesome. Okay.
So this, and as with these kinds of things, like I went through like a couple of months worth of like just caning it every night, trying to beat it into shape, and then breaking it beyond all recognition. Because of course, when you're doing this stuff, you don't check in for weeks at a time. Maybe not weeks, but you know what I mean. It's like you do, bad behavior sneaks in, right? I'm not going to lie, and but yeah, I mean, I look forward to when I can sort of start investigating literally the Smalltalk stuff, like in more depth. But really, my interest to begin with is, making sure that it's a legit sort of VM setup. For example, there's some Perl code that is used for primitive generation, which I haven't been able to find. I think it may have got missed. Like there's a couple of branches kicking around in SVN as was. So I forget which zip file I took it from. Also, there's a couple of forks on GitHub as well that I looked at.
Really? Wow.
Stephen Reese is the.
I know Stephen's work. I don't know anybody else who did anything with it.
I mean, he's the main guy, to be fair. And then because he was mainly working as far as I could tell from sort of archaeology, he was trying to get it working under Linux. But actually, to get back to what I was saying, the point is that say you wanted a X Windows type thing, what you have to do in the Strongtalk model, I should say, is within the image itself, make your X calls to, I can't remember any X calls off the top of my head, but X open window and that kind of stuff. You literally have to define those as calls within the language, within the image, and then that would go through the FFI to actually do the right thing. So that's how you'd have an X Windows capable image and a Win32 one. And if you were really clever, eventually you'd have one that was smart enough to know under what architecture it was running and do the right thing. But that's a long way off yet.
Yeah, but making that FFI 64-bit, I suspect, is pretty hard, actually.
Oh yeah, I mean that. I mean, just to give you an idea, I mean, it's not helped by the fact that it's basically a Win32 application that I'm running and debugging under Wine, and I have.
Yeah, that's dubious to begin with. Yeah.
I have tried. Well, I'm lying, of course. I haven't tried to get it compiled under Visual Studio, but that's really just because I'm too much of a bigot still to really try it. But I probably should. I mean, just to give you a kind of a flavor, the reason why it's broken at the moment is I said because I've been trying to use. I mean, stuff like it is actually a really fascinating thing in some ways. So tell me to shut up if you've got something better to talk about. But if you imagine C++ 98 or pre 98 to 20, and I don't even mean things like lambdas and all this kind of clever stuff. Like back then,
we got it to build again in 2006, I think, the last time. So
right.
And that already was painful because it already C++ had moved far enough that it didn't just work.
Well, I mean, I'm talking about even using things like int32t, right? And just standard type names. So I've been sort of quite religious in going through and making sure that everything is like explicitly named like that. Probably sort of wrongly, but it's yeah. I mean, take a look on the GitHub, and I'm not quite sure what state it's in, but yeah, it's certainly. And the interesting thing is actually there's a certain number of VM images that I found on the web. I think I found 3 or 4. One has got OS X stuff for Mac in it.
Yeah.
One has got Win32 stuff that I'm using, and then I think there's a Linux one as well. And I've explained what the differences are between them. But yeah, I mean it's there's some it runs quite well, and then sometimes when you dive to you have a class browser and you dive too deeply down, then you gets caught in a kind of a tight loop and then loses grip. But I think it's as you guys do, right? You always do the 4+3, and it basically works. So like Strongtalk basically works, so it can't be that difficult to fix.
Yeah, well, one hopes it would be cool to see that actually, I mean, the old binaries work, right? I demoed this on occasion with old stuff, and it works. It's not terribly solid in the best of times. I mean, it works, but it is not production quality by any means. Because this was basically some old tape that Robert Griesmer, when I finally got Sun to agree to let go of it, and that had already been like 9 years, and we didn't have necessarily and it was under active development. It wasn't necessarily the best version we had to begin with. And then, of course, everything's moved. So, but yeah, I miss the snappiness of it. It really was pretty nice that way. I really would like to see that, but it's a lot of work, and yeah, I'm interested to see how it goes.
Okay, well, when I next dive into the next sort of round of stuff that when the mood takes me, I will, and I make some progress, I will certainly let you know.
Cool.
Yeah, we'd love to see it here too.
Sure thing. I mean, it would absolutely be my pleasure. Yeah, and the other thing I should just add, I mean, you mentioned Robert Griesmer. If you look through the authors list, and I've been careful to make an acknowledgements.txt file at the top of the source tree, is that it really reads like a who's who of kind of sort of computing.
It was a pretty damn good team. I don't know what I was doing there, but the rest of them actually knew what they were doing.
There's some big names in there, and so like I said, I picked up the SICP book to sort of learn Scheme, and
good book.
Then yeah, fantastic. I mean, and a whole kind of sort of to steal it's a kind of a golden age, I think, really, of things. Really,
if you like that book, you should check out Lisp in Small Pieces.
I have that as well. I think I bought the whole Lisp canon back there, really, just to be a complete, dickhead, really. And I succeeded quite well at that. And the other thing, actually, just while I'm to this audience, the thing that really turned me on to the whole, the reason why I'm here talking to you today, is Alan Kay's 1997 Oopsla talk, in which I was just kind of, it was a bit of a mind blowing, and he mentioned in that in that talk, The Art of the Meta Object Protocol, which is another similarly mind melting book, which I haven't quite got through. But I almost have, because I realized once when I was trying to write a messaging system in Python that I didn't know it at the time, but I was dabbling in the dark arts of the meta object protocol. But yeah.
Cool.
Well,
like I said, more USB than PhD, right? So.
Well, that way you get things done instead of talking about them. That's always.
Well, like I said, when I do get the next round of stuff done, I'll be sure to let this audience know.
Very good. Okay,
Nice.
Thank you all.
Yeah, thank you again. Thanks, everyone.
Thank you, Gilad.
Bye.
See you.
All right, I'm gonna go. Cheers, guys.
Yeah, cheers. I gotta go too. And no offense, but I'm going to start booting people out of here just for security's sake. The text chat will be available.